Okay, this next example is in standard form already, so it makes it easy to find the horizontal asymptote when it's in standard form. I compare the highest powers of x, so x squared over x squared over x squared. They both match, so basically I have a 1x squared over 1x squared, which would just simplify to a y equals 1. So that is my horizontal asymptote there. To get my vertical asymptote or whole, I would need it in factored form, so let's go ahead and factor. You might remember that you're looking for what multiplies to -6 and adds to a +3. So that's an x plus 3 and an x minus 2. On the bottom, you are looking for what multiplies to a -2 and adds to a -1. So that gives me an x plus 1 and an x minus 2. And then I see what I can cancel out. So in this case, we would be canceling out the x minus 2's. And I would have an x plus 3 on top and an x plus 1 on the bottom. The factor that cancels out, remember, makes a hole. Something that cancels out makes a little problem, makes a little hole in the graph. Something that doesn't cancel out makes a big problem, makes a vertical asymptote. The x-coordinate for the hole is x equals 2. The x-coordinate for the vertical asymptote is based on this factor that does not cancel out, this x plus 1. So x equals -1 would be a vertical asymptote. To find the y-coordinate of the whole, of course, I could take the 2 and plug it into where all of my remaining x's were after I simplified. So I would have a 2 plus 3 on top, which is a 5, a 2 plus 1 on bottom, which is a 3. So my whole would be at the point x equals 2, y equals 5/3. We'll go ahead and graph that in Desmos and make sure what we're getting is right. Okay, so vertical asymptote was supposed to be x equals -1. Type that in. You notice that goes right in the middle. Both pieces are getting closer to it without touching it. Horizontal asymptote of y equals +1. Once again, both pieces are getting close to it without touching it. To check the whole was supposed to be at +2 5/3. Well, I can look at the graph and see it comes close to +2 5/3. And if I drag very carefully, you notice right at 2, it will tell me it is undefined. So that lets me know that the x-coordinate of my whole is correct because it keeps going to undefined. Another way you can check for a whole is you can take your original equation, click there, and get your gear, switch to a table, and if it is a whole there, a whole or a vertical asymptote will give you an undefined value on the table. The vertical asymptote you can clearly see on your graph as x equals -1. You notice I don't see a problem at 2, but that problem I do not see is actually that undefined point, that hole. So once again, the factors that cancel out make a little small hole. The factors that don't cancel out make the asymptote, and either one is going to be an undefined value in your domain, a restricted value that is going to show up on the table as undefined. We'll go ahead and try one more example. On the next one, it is already in standard form. So what I can do is I can compare my highest powers. Once again, so my horizontal asymptote is going to be 2x squared over x squared. That would simplify to just y equals 2 because the x squareds will cancel. And to get my vertical asymptotes, I would need it in factored form. So the top will not factor, 2x squared. The bottom would factor as x plus 3, x minus 3. If you don't remember how to factor that, you could have always put the denominator in Desmos to find the factors. This has no holes because there's no factors that cancel out, so you can just put none, or I'll put an N for none. And then vertical asymptotes would be what makes the factors that don't cancel out equal 0. So you should have x equals -3 and x equals +3. We'll go ahead and graph this one in Desmos to confirm our answers. So when we get this graph, you can see the vertical asymptotes at -3 and +3 seem to be the branches are getting closer to but not crossing. The horizontal asymptote at 2, in this case, both branches are getting closer to it without crossing. Don't worry about the fact the parabola in the middle doesn't quite get there. As long as at least one branch gets close to it, it is a correct horizontal asymptote. And your table, notice, doesn't show the 3, but if we were to type a 3 into my table,